Question number 6. Which function, when graphed, would not intersect the x-axis? So we essentially want a quadratic function that would look something like that. It would be just above the x-axis or below, but in that case it just cannot touch the x-axis, which is the horizontal line right here. And by setting y equal to 0 for a quadratic function, we can find where the graph of each function intersects the x-axis. Okay, so we can set y equal to 0, and like that, we can determine where the function intersects the x-axis by finding the values of x by solving the equation. So how do we go about this question? How can we easily determine which one would not intersect the x-axis? Well, the graph will never intersect the x-axis if the equation has no solution. And for this type of equation to have no solution, the discriminant needs to be negative, or in other words, smaller than 0. Remember that the discriminant is just this portion of the quadratic formula. And if that's negative, we have no solution. So we just need to determine which one of these would have a discriminant that is negative. Let's start with D here. I have a feeling that that will be the answer. So let's plug A, B, and C in for the discriminant. A is 4, B is negative 12, and C is 10. So negative 12 squared minus 4 times A times C. Negative 12 squared is 144. 10 times 4 is 40, times 4, 160. 144 minus 160 is negative 16. So we have a negative number for the discriminant. So D is the answer. I lucked out in this case to try it right away. And that means, of course, that the function looks something like this. It's just essentially above the x-axis, and it does not intersect it. That's it.